Hello, for this lesson we are talking about the Pythagorean Theorem. The Pythagorean Theorem is basically a formula that is going to allow us to find missing values when working with right triangles. Okay? We're looking for the missing side lengths when we're working with right triangles. It doesn't work for any triangles but right triangles. Okay? So our formula here we have on the left side, and it's a squared plus b squared equals c squared. Okay? A and b, those are in blue, and those represent the two legs. Okay? These are the two shorter sides, okay, that come together and meet at the vertice of that angle, that right angle. Okay? The C, that's the longest side, and it's called the hypotenuse. Notice that the C is on the other side of the equal sign. Okay? So we use this formula and we're able to find missing lengths. So we have 4 examples here. Let's tackle number 1. We have a right triangle here, and it has one side length of 7 miles, it has one side length of 23 miles, and then a missing side length, it's labeled as B. Okay? So let's solve number 1. So number 1, I use my formula, a squared plus b squared equals c squared. Okay, well, I'm going to say since they're labeling this b, I'm going to guess that, well, we can use that as our b value. Okay, make sure that these are the legs. Remember, that's the shortest two, and they meet at the vertex of our right angle. Okay, so it works for me, right? That's a leg. So we're going to have b squared. We know that a, if that's the other leg, that's 7 squared plus, and then we have 23 miles. Okay, I don't need to have miles in this problem since I'll bring it back at the end when I'm labeling my value, but to work all this algebra, I don't need to write the values. Okay, so, well, I've got 7 squared is 49 plus b squared, and then it equals 23 squared. So I'm going to solve that out. 23 times 23. That gets me 529. Okay. Well, from there, I need to start doing inverse operations in order to simplify this and isolate my b. I need it to say, instead of saying, 49 plus b squared equals 529, I need to know simply what b equals. So here's how we do it. We subtract 49 from both sides. We're taking inverse operations to get us where we need to go. That's going to be 480. Okay, I get b squared equals. Okay, well, again, I don't want b squared, and so what we need to do is, since I just want b, well, I need to undo b squared. I need to get rid of that squared. So what's the opposite of squaring a number? Well, it's finding the square root. So what I'm going to say is, well, I'm going to find the square root of both numbers. Okay, so b squared, well, the square root of b squared is just going to be b, right? Because the square root will undo b being squared. And then over here I have the square root of 480, so let's plug that in. And I get 21.90890. It continues on. So I need to look at the instructions. What do the instructions say? It says round to the nearest tenth if necessary. So my number was 21.90, which means I'm going to just end up with 21.9. And then, remember I said we don't need to include the miles when we're doing all the algebra, but we do need it in our answer. So it's 21.9 miles. All right, let's take on number 2. Okay, for number 2, we're given 9 meters, 15 meters, and C. Well, let's make sure, usually in Pythagorean Theorem, C represents our hypotenuse. We need to make sure that's true. C is our longest side, right? Our legs meet at the vertex of our right angle. So we know that C, that works for us. So it's going to be 9 squared plus 15 squared equals C squared. Okay. And notice I didn't spend too much time deciding, well, how do I know 9 is A and 15 is B? Well, it doesn't really matter which value I select, because that's just working with the commutative property of addition, right? I could have written this problem as 15 squared plus 9 squared equals c squared, and that's just the commutative property of addition. It doesn't change the problem, okay? So the legs, it doesn't matter which one you put in A or B, as long as you're truly putting in a leg. If you put a hypotenuse in to one of your leg positions in your theorem, then you're going to have an error. But if you're putting the legs in the A or B, it does not matter, okay? Well, 9 squared is 81 plus 15 squared. Well, I don't know 15 squared off the top of my head right now. So let's solve that out. I've got 225. That equals c squared, okay? Then I needed to add those together. Since these are on the same side, remember this one, we subtracted 49 from both sides. This one is different because they are on the same side of the equation, which means I just add them together. That gets us to 306 equals c squared, okay? And remember, I need to then find the square root of these two values because we are undoing c being squared, okay? So square root of 306 is 17.492855 goes on. Okay, so I need to round to the tenths place. It's going to get us 17.5 since it rounds up, and it's in meters, and that equals C. All right, for number 3. Number 3, we have another right triangle, and we ran into something a little different this time. Okay, what's different in this one is that we don't have an A, B, or C, okay? And what that means is we need to just simply identify, is it the hypotenuse or is it one of the legs, okay? And we notice, right, the longest side is the 20. The longest side is the 20, and then the x, that's one of the sides that meets at the vertex of the right angle. Okay, it's one of the shorter sides, making it a leg. I don't care if it's A or B. Remember, we talked about that in problem 2, where it doesn't matter if I plug it in for A or B. That's the commutative property of addition. Okay, so I can say, 16 squared plus x squared equals 20 squared. Okay, and does it matter that I'm using x as my variable now instead of b? Well, remember, variables it's really what you choose them to be, okay? In this example, in example 3, it's given us an x, so I'm solving with an x, but I recognize it's just that principle, that I need a variable squared plus a variable squared equals, some other variable squared. And it doesn't matter if I use x, y, and z, or a, b, c, or, any values, okay, or any variables, as long as I understand what can go in these two areas, right? These are the legs, that's the hypotenuse. The variables can vary. Okay, so here we go. So 16 squared is 256 plus x squared equals 400. Okay, now again, this one is back more similar to problem 1, where we need to subtract 256 from both sides because our two constant variables or constant values are on the other side of the equations. So we need to do the inverse operations. Okay, that gets us to x squared equals, we get 144. I do believe. Yep. Okay. So then, remember, we need to do the square root of x squared and the square root of 144. And that's going to get us x equals 12. What's the value of distance? The measurement is in inches, so we write 12 inches. And lastly, we have this final triangle. So, okay, well, this time what are we missing? Well, it has a y, so again, we need to identify what it is. It's my longest side, that makes it the hypotenuse, okay? It's given us the two shorter sides, the legs. Okay, so I'm going to do 15 squared plus 36 squared equals y squared. Again, we don't necessarily need to have the c, we just need to understand what is missing. What is missing is the hypotenuse. We have both legs. Okay, So 15 squared, we already discovered earlier, is 225. Okay, and then we need the square of 36. So 36 to the second power is 1,296. That equals y squared. Okay. Well, since those are on the same side of the equation, our two constants, then we add them together, getting us 1,521 equals y squared. Well, again, we need to find the square root of these values because I need to undo y being squared. Okay, so I'm going to get y, and let's find the square root of 1,521. That's going to get us simply 39. It's a perfect square, so that's very nice. It's 39, and what's the measurement? It's in centimeters. So that is a brief lesson on the Pythagorean theorem and how to utilize it to find missing values. Good luck!